We're going to talk about serendipity, but I'm going to have to shorten my talk because we don't have much time. So let me skip the first few slides and say a few things. Oh, I can't see you well. The title of the talk is Does Science Evolve by Blind Chance or by Intelligent Design? And what I mean by that is does science, should we do science the way I was taught science is in high school? That is to say, by the so-called scientific method. You formulate a hypothesis, and then you figure out a way to test the hypothesis, and then you make the experiment or the observation and see whether what is predicted takes place. If the experiment succeeds, you have evidence for the hypothesis. If the experiment does not support the hypothesis, you can reject the hypothesis. Now that's often how science goes, by direction. To give a more practical example, during the Pacific War, when we wanted the Second World War, when the United States wanted to put an end to the German war as rapidly as possible, we set out to build an atomic weapon, and of course we were successful in that endeavor. And to the great shame of my country, it was used twice against Japan. But that's an example of directed science, if you could call it science. It also resulted in the development of nuclear power, which is a very positive development. Now, the other way of doing science, or rather the other approach, or the other possibility, is serendipity. That is, you set out to do something, and you notice that things are not going quite the way you expected, and you discover something quite different. The one example I will mention, I just mentioned one example right away. One of my favorites is a experimenter was trying to develop a new yellow dye back in the 19th century, and unfortunately he got this beautiful chemical, but it exploded. And then he realized that this was something quite useful. It was TNT. Another example, I mean there are many, is the discovery of Viagra, which the medical profession is very aware of. It was supposed to be a drug to have something to do with heart disease, and it was in some final stage of testing, and it was observed that exactly half of the patients that were given the drug had a very conspicuous side effect. It was the men. So the drug, in fact, had nothing to do with heart disease. It was useless for that purpose. It is Viagra. Okay, so much for that. Let me go on to, how do I turn pages on this thing? You push one of these buttons. This button? Oh, okay, so that's, I just talks about those various things. Now, let me make one further remark off the cuff. Let me give two examples of this approach to science. There was, on the one hand, Christopher Columbus. You will know about him. He tried to sail off from Europe and find China. He failed in that endeavor, but he was successful nonetheless in quite a different way. He discovered, or he was the first European to get to America. Whereas one of his competitors, another adventurer, Portuguese, decided to sail all the way around the world, the other way, and he succeeded, sailed all the way around the world. So those are the two contrary ways in which science can develop. Now, since I was coming to China, I decided to mention a couple of examples of Chinese serendipity. There they are. Searching for the elixir of immortality, Chinese alchemists in the Tang Dynasty mixed saltpeter with charcoal and sulfur and ended up with something that exploded, and it burnt down the house. They survived. They had discovered gunpowder, which is one of the 5 great discoveries that we credit to the Chinese, along with paper and printing and so many other things. And then there's the next is rather mythological. There's a mythological emperor the Yellow Emperor, I'm told, taking tea with his wife under a mulberry tree, and some object from the tree fell into her tea, and she realized it was a cocoon of whatever worm it is that makes silk. She unwrapped it and got this long thread and made a robe for the emperor, and the emperor liked it very much, and that began the silk industry. That's, of course, mythological, but it's another example of serendipity. And, of course, I don't have to mention the compass, the magnetic compass. That could only have been discovered accidentally. There's no way they could have set out to build a magnetic compass, and it was by luck. Let me go through a dozen examples of serendipity. In 1781, a very famous astronomer, William Herschel, accidentally found a new planet, and he found the seventh planet, Uranus. Most of his work was much more directed and much more planned, much more controlled. Then, a few years later, remarkably, in 1800, he goes on to discover black light, which is infrared light. He was wondering which color of the 7 colors of the rainbow carries heat. You feel heat when you go out into the sun. Did it come from the red or the yellow or the green or the blue? So he set up a bunch of thermometers, and just by accident there was one thermometer lying on the wrong side of red, and it's the one that got hottest. So he discovered infrared radiation totally by accident, following up some other idea. By the way, just a year later, ultraviolet was discovered, and that was highly systematic. That was found by someone who argued on the basis of symmetry, some Kantian philosophical principle, that if something funny was going on one side, then something funny had to be going on the other side. And so he found another form of invisible radiation. Faraday, then there's Ørsted and Faraday, two of the giants of electromagnetic theory. Both did remarkable experiments. Ørsted, doing an experiment, he didn't notice it. His students noticed that when he sent a current through an electric wire, he was trying to show was that something he knew, that current going through an electric wire makes it get hot. The student said, when you turn that electricity on, the compass needle moves. Then he discovered the first relationship between electricity and magnetism, that electricity can make magnetism. And some years later, Faraday discovered by accident the opposite, that magnetism, if it's changing, can make electricity. A completely unexpected result. By the way, he then went on to try to show if gravity can make electricity. He failed in that endeavor. Radioactivity I'll talk about later. That's one of my favorite serendipitous discoveries. It was inspired by another serendipitous discovery, that of X-rays. Completely unexpected. Penicillin, of course, was discovered by accident, but on the other hand, streptomycin was discovered by plan, by design, as were many other of the antibiotics. What's next on that? Oh, the positive electron electrifies Carl Anderson, an American physicist who was studying cosmic rays and found, to his surprise, that there existed particles like electrons, except they were positively charged. Particles that ultimately had been predicted to exist, but he didn't know about that. There's the the discovery of LSD, lysergic acid, and that was quite a surprising discovery when he realized that it made him have wonderful visions. In 1974, two physicists, one on the east coast of America and one on the west coast, and their collaborators, discovered a particle, one of my favorite particles, the J-psi particle, which is made of a charmed quark and its anti-quark. And one of those discoveries was quite accidental. I mean, the Californian version of the discovery was an accident and a surprise and an example of serendipity. And the Eastern discovery by Samuel C.C. Ting, one of the greatest Chinese-American physicists, was by design. He had a plan, he had an idea, and he was right. So sometimes it goes one way and sometimes it goes the other way. I'll give a couple of other examples. There have been so many. The discovery of buckyballs, the discovery of graphene, many, many discoveries in physics have been entirely accidental. The electromagnetic spectrum, let me just say about a few things about it. I mentioned Isaac Newton. He was the first person to split light into its different colors, but in a completely systematic fashion, he identified the 7 colors. He is the one who decided there were 7. And to me, I always thought there were only 6. I don't know the difference between indigo and violet, but in any case, there are 7, and he made them 7. That was a deliberate bit of work. And then William Herschel, as I mentioned, accidentally fell upon infrared radiation, and a man named Johann Ritter, discovered by design rather than chance ultraviolet radiation. Heinrich Hertz, very much by planning. He was one of the few physicists of his day who had studied electromagnetic theory, and he discovered radio waves by deliberation, whereas quite by accident Roentgen discovered X-rays, and quite by accident Penzias and Wilson, 2 Nobel laureates, discovered the cosmic microwave radiation, which is what has told us so much about the origin of our universe. And there have been a lot of further discoveries that resulted in our present understanding of electromagnetism. Most of them were by design, like Mr. Ohm, who discovered the famous law that you learn as undergraduates that relates to the voltage to the current through an object. That was discovered by design. I'd like to talk a little bit about Henri Becquerel, Henri Becquerel, the discoverer of radioactivity, because this is a perfect example of what I call triple serendipity. So he was inspired by the discovery of X-rays by his German friend, and he decided that if X-rays can be produced electromagnetically, perhaps they could also be produced naturally. And he and his father before him had studied cold light such as luminescent chemicals or fireflies or other instances of light that is not affiliated with heat. And he took a luminous chemical, and he had the theory that when it would be exposed to light, and that meant sunlight because that was the only intense light they had, that it would produce X-rays. And so he did an experiment to test this hypothesis. He put the luminescent material in the sun and wrapped it up with a piece of photographic film. Perhaps there was a key in between. Then he developed the film, and he found that there was an image. So he thought he had proven his hypothesis, which, by the way, is not true. Luminous materials do not produce anything except light. So he decided to repeat the experiment, but this was Paris in wintertime, and the sun didn't come out. So he had his luminescent material wrapped up with a photographic plate, and he put it in a dark desk drawer, and he waited and waited and waited for the sun to come out, but the sun never came out. So what the hell? He developed the film, and it was exposed. And that told him that the sun had nothing to do with the story, that luminescent materials don't make X-rays, that something else was going on. And a particular material Serendipity 1. The particular material he used happened to be the luminous material, a salt of uranium, which happens to be luminescent, having nothing to do with radioactivity. Secondly, what if the sun had come out? If the sun had come out again, he would have done the experiment again, and he would have written a paper saying he had proven that luminous materials produce X-rays, a false paper. And third, why did he develop this thing that was lying in his drawer? His son, also a physicist, had no idea of why his father bothered to do this, but because he did that, because he had that little bit of extra curiosity, he made an astonishing discovery, an example of triple serendipity. That just repeats what I said. A number of chemical elements were discovered accidentally. I just mentioned a few. There only are a few. Phosphorus, hydrogen, iodine, argon, neptunium. I'll mention only a word about argon. So this guy at the end of the 19th century was trying to measure atomic weights with great precision in order to check what was called Prout's law. We'll come back to Prout's law. And he made precision measurements of oxygen, and he found that the atomic weight of oxygen is not an integer in units in which hydrogen is 1. And then he tried nitrogen. But trying nitrogen, he was a very careful experimenter. He took nitrogen from the air, and he took nitrogen from decomposing ammonia, and he got different answers from the two. And he discovered the most embarrassing thing that ever happened to the profession of chemistry, that 1% of air consists of an element that no chemist had ever heard of until he discovered it. That was he and his colleagues. That was a fantastic discovery. Then there was neptunium. That's the most recent serendipitous element. But onwards. Prout's law, vitalism, and the color purple. Tyrian purple was once the most precious of dyes. It was used from ancient times. It's made from fermented sea snails. And it makes a terrible stink, a terrible odor to produce this dye, it is said, that Jewish women who were married to dyers, people who used dyes and would use in particular purple dyes, were entitled to divorce because of the hideous smell that would be associated with their husbands. Anyway, that all came to an end with the Crusades. When the Crusaders came and destroyed Byzantium, the secret recipe was lost. It's been refound some years ago, but it's not commercially significant. There are other purple drugs. We'll come to that. Now, back in those days, coming back to the measuring of atomic weights, remember that this man Prout had predicted that atomic weights would be integers. It turns out they're not, but all atomic weights are almost integers, and that is very meaningful. That has told us a great deal. So he wasn't entirely wrong. But he didn't publish those papers because they were too speculative. Instead, he published a paper on a dye, a purple dye that he had produced from snake feces. And that actually didn't do well commercially. So that's all I have to say about him. But then we come to one of the most astonishing accidental discoveries in chemistry, and that was the discovery that it was believed back in the old days that organic chemicals contain some vital principle, some thing that lies outside of the natural world of physical phenomena, something essential to life. And therefore, you could not synthesize organic chemicals. And then he went about synthesizing urea, quite by accident, and he was amazed, and he wrote to his vitalist colleague. Vitalists are people who believe in principles lying outside of the conventional scientific domain, energies and forces that are in your body but nowhere else. Anyway, that was the end of vitalism to most of the people in the world. But of course there are remnants, that people who still believe in exotic forces and energies, but that's not a good idea. serendipity and the color of money. Many of us here are interested in money. Most of us are interested in money. And dyes have frequently been associated with chemists making serendipitous discoveries. Here are a few of them. So going back to 1704, using cheap ingredients, probably contaminated, a paint maker accidentally produced the first synthetic coloring agent that went commercial, and that was what we call Prussian blue. It was accidentally discovered simply because he was using dirty chemicals. Then in 1846, the story of Henry Perkin is very interesting. He was 18 years old, an Englishman, probably as talented as Sir Richard here, but only 18 years old. He was really interested in chemistry, and it happened that a German chemist was passing by and told the young fellow that he should synthesize quinine from the destructive distillation of wood. Well, that was pretty bad advice, and he set out to do just that, and he made, in fact, I did experiments like that when I was a kid, and you always end up with a terrible mess. So he ended up with a terrible mess, but he noticed that somehow the mess that he made had a purple color, and he extracted from that mess a dye which became known as mauve, was worn by the Empress of the Second French Republic, was worn by Queen Victoria. He became extraordinarily wealthy, and then he went back to academic chemistry. So that's a rather interesting way in which accidents, in which you can be led astray by what you were doing. We all know that quinine was discovered in a highly dedicated, planned way during the Second World War by a couple of Harvard chemists. By the way, although I'm a professor at Boston University and I'm not a professor at Columbia University, I did spend 35 years as a professor at Harvard University. Then in 1859, it goes on because the German who had told Perkins about the first dye went back to Germany and discovered the second aniline dye, more, but that was not an accidental discovery at all. No, the first one was more. Whoops, sorry, I just said. I'm going back. I'm going forward. I'm going on to the. Yeah, where am I? Well, I'm not going to do this. We don't have time. I mentioned TNT. It was another dye maker looking for a yellow dye who ended up with TNT. In 1897, a carelessly broken thermometer led some guy named Eugen Saka to identify mercury as a catalyst to make indigo. That was another important discovery, completely accidentally. Another defective glass vessel leaked iron into some mixture. God knows what the guy was trying to do, but the guy discovered another dye quite by accident, Monostrol blue. So the dye industry is covered with accidental discoveries. By the way, that German turned out to be very important, that German advisor to the Englishman, because he basically was responsible for creating the German dye industry, which was enormously successful. Serendipitous Nobels. Well, you've seen so many Nobels here. They've all told you their discoveries were largely serendipitous, so I don't have to go through this list, but there are an awful lot of them. Even a lot of people who are not here. I might mention a few, but I won't because I don't have enough time, so you will forgive me. That's some of the accidental Nobel Prizes. Now, we're all interested in the technological consequences of serendipitous discoveries, and it's interesting that there can be short delays or long delays between the discovery and its practical application. I give a few examples here. The GMR effect is the giant magnetoresistive effect. It was discovered by a Frenchman and a German independently, both of whom won the Nobel Prize. And within 3 years, that effect, which had to do with the large changes in the magnetic properties, well, whatever, made it possible to, for the first time, to have gigabyte hard drives, and there was an explosion in the memory capabilities of computers. Took 3 years. From the discovery of the charge-coupled device, which is another Nobel Prize-winning discovery, it took 6 years before digital cameras became commercial. For the transistor to the transistor radio, I think the Walkman was the first commercially successful transistor radio, took 7 years. From matter waves, de Broglie, one of the founders of quantum mechanics back in the early 20th century, from matter waves to the electron microscope took 10 years. From radio waves to Marconi and the first wireless telegraphy took 11 years. From fission, from the German discovery of fission to the English-American discovery of nuclear power, took 19 years. From general relativity to the global positioning system, it turns out that GPS could not work unless you understood the general theory of relativity. So that took a long time. That took 78 years. And from the discovery of photovoltaics are materials that produce an electric current when you shine light on them. They were discovered, by the way, by Becquerel's father, Becquerel, the discovery of radioactivity. It took 115 years before we started distributing, making solar panels in order to produce electricity. And there can be various reasons for the delay. In the case of some cases, such as nuclear power, it was war that was the motivating feature that led to the application. In the case of solar panels, it was necessity. We realized that we're burning too many fossil fuels, and so it goes. I have 6. I'm not going to talk to you about them. I don't have the time. I don't know how much time I have, so I'll just go along with a few of them. There are 6 Western sugar substitutes. I know that in China, mostly you use an ancient product, ancient and honorable product called stevia as your artificial sweetener, and that was not discovered serendipity. That goes back perhaps 1,000 years. But in the West, we had saccharin. Now, saccharin was discovered by a person called Faubourg. He fails to wash up after work and goes home, and he notices a very strange sweet taste on his tongue. He discovered saccharin, accidentally. In 1937, another careless chemist, a graduate student studying a possible anti-fever medicine, puffs a cigarette he had left on the lab bench. See, maybe you shouldn't give up smoking, because some of many discoveries come from chemists who smoke. He was working on an anti-fever. He puffs a cigarette that he left on the table. He notices a sweet taste. He discovered cyclamate. Now, interesting. Saccharin was declared to be carcinogenic by the Canadian government, and it was banned. Whereas saccharin was banned in Canada. Whereas cyclamates were, according to the American government, caused cancer. So they were banned in America. And there was a product called Sweet and Low, which people use to sweeten their tea or coffee, which in Canada contained cyclamates, and in America contained saccharin, because each country decided the other chemical caused cancer. Of course, neither causes cancer. They were just other examples of troublemakers, such as Sir Richard had talked about it in the case of GMO. By the way, I signed that document, of course, and you should as well. 1965, this is a nice one, the last one I'll talk to you about. This guy Glashow was searching for a new ulcer or heartburn medication. He accidentally spills a chemical on his hand, looking at his finger, turning the page, and then he discovers aspartame, another one. I can't resist one more. Wait, there's one that's particularly interesting. Interesting because it's British, and my British friend is here. It was in 1976, a British researcher asked his Indian graduate student to test a carbonated sugar compound. The guy was called Shashlikant Fadnis, and he didn't speak English very well. And he thought his professor said, taste the chemical, not test the chemical. So he tasted it, and it was sweet. That was sucralose, which is a perverse sugar containing chlorine. And there's others. Now, a lot of you are interested in the medical sciences, so I hear you're familiar with this, all these accidental drugs. All of these drugs were discovered serendipitously. Librium for the anxious, phenacetin for aches, Naftin for athletes' feet, Rogaine for people without hair, Niazid for consumption for TB, Tafranil for the sad, Revia for the drunk, Sucralose for the fat, LSD for the foolish, Clonidine for hypertension, Haldol for hysterics, Warfarin, which is rat poison against blood clots, antibiotics for ulcers, Mustine for lymphoma, that's a long story and very interesting in itself, Prednisone for the inflamed, Viagra for the impotent, thalidomide for lepers and also for certain cancers. First use of thalidomide was a disaster, but it turned out to have other very good uses. Lomotil for the loose, lithium for the manic, Thorazine for psychotics, penicillin for pustulence, Quaaludes for insomniacs, Retina A for, okay, I don't have to read them all. And then nitrous oxide, that was discovered by chemists who had a lot of fun inhaling nitrous oxides, and it became, of course, an important drug for dentists to use. Okay, go home, and it's full of serendipitous things in your home. Serendipity is everywhere. Post-it notes, for example. Those are those little things you write messages on saying, buy cabbage or something, and you stick it to the refrigerator. It was this person working on glues, on adhesives, produced an extremely lousy glue. It didn't stick very well. Now, what good is that? Post-it notes. An application of a search for adhesives which seem to have failed. Super glue is very useful when you break things that you shouldn't break. My glasses are made of polycarbonate lenses, polyethylene, Teflon, Velcro. Well, you can read the list yourself. All of those things were, including ice cream cones, were accidental discoveries. A lot of toys in there, rubber erasers. Rubber is very interesting. The story of rubber erasers. A quick story. So, rubber had been discovered in the New World, of course, and they brought samples of it back. And it was not called rubber; it's called caoutchouc. In most Western languages, in French and Spanish, it's something like caoutchouc. And back in those days, the pencil had been discovered. The pencil without the eraser, and people wrote in pencils. But in order to erase what they had written, you know what they used? They used a piece of bread. They would rub the message with bread, and that would remove the graphite, and it would be an eraser. And this guy got some rubber that was sent back from the New World, and he rubbed with the rubber, and he found that it erased the thing. And that's why rubber is called rubber in English. I don't know what it's called in Chinese, but we call it rubber, the same as to rub with. Anyway, lots of accidental discoveries. This is one of my last slides, and here I discuss serendipity in my field of theoretical physics. So the same phrase repeated. Surely Maxwell was amazed when he showed that his equations described the electromagnetic waves we call light. Surely Schrödinger was shocked finding that his waves and Heisenberg's matrices described the very same theory that we today call quantum mechanics. By the way, let me say another thing about quantum mechanics. The history of quantum mechanics is astonishing. There was this time in the early 20th century, starting in 1900 or so with Planck's work, when there were a bunch of young people, people like Heisenberg and Dirac and others, who were friends with one another. They would often meet together in Copenhagen, and they had a tremendous amount of fun trying to understand. Fun, that's what it's all about. That's what science is all about. Fun, trying to understand the atom. And they fooled around and they built this wonderful theory. They didn't have any patents, not one. They didn't have any confidentiality agreements, not one. They didn't have any salable product, none. They just had fun. Now, after all is said and done today, something like 30% of the world economy is contingent upon an understanding of quantum mechanics. 30% of the world economy resulted from a bunch of kids having fun and not making any money. Anyway, these two guys, Heisenberg and Schrödinger, had discovered different versions of the same theory. Surely Dirac was dumbfounded when he realized that his equation, which describes the electron, predicts the existence of another particle which was discovered in the laboratory, antimatter, the antiproton, the anti-electron, the positron. Surely Murray Gell-Mann was one of the tutors and one of my mentors and a very close friend, and he invented quarks, but he didn't believe in quarks as anything real. They were fictitious. And he must have been absolutely flabbergasted when it was realized that quarks are real. They're in there. And surely string theorists were stupefied when they discovered that their attempt to understand the strong nuclear force demanded the existence of gravity. They claimed that they had predicted gravity, but we knew about gravity long before we knew about string theory. Finally, I wrote this paper in 1960, which was the paper that won the Nobel Prize for me, which I shared with my high school buddy, Steve Weinberg, and Abdus Salam, one of the first Muslim scientists to win the Nobel Prize. And I'm absolutely amazed that the work we had done so many years ago turned out to be now in the textbooks we give to our freshman physics students. One more slide. And that's the nothing can be done without super in front of it. There is a super collider, which doesn't exist. There's superconductivity, which does exist. There is now super serendipity. And super serendipity is when a discovery or a series of discoveries has immense consequence. And I mentioned, of course, quantum mechanics. A few others are number theory. Without number theory, we could not have secure banking. General relativity, without which no GPS. What did I have here? Faraday's law, without which we could not generate electricity. And the worldwide electrification depended on Mr. Faraday. The World Wide Web, which was discovered at CERN by physicists and for physicists, but everybody else seems to have cottoned on to the idea of the internet as well. And by the way, particle accelerators. You know, why do we build accelerators? Why do we have this giant accelerator in Europe, which is cranking out new information? Why are you Chinese, some of you, thinking of building the next world's greatest accelerator? Why do that? Well, there are 20,000, maybe 30,000 accelerators in the world, and very few of them are doing fundamental basic physics. They're doing industrial things. They're testing things, they're making things, they're studying things, and they're curing cancer. Whole lot of other things to do with accelerators. And on that promising note, I thank you all.